introduction on Achronix. We were founded in 2004 at Cornell University, and initially we developed high-end self-timed or asynchronous FPGAs. But in the last 8 or 9 years, we've kind of switched gears a little, and we've been focusing more on the traditional high-end synchronous FPGAs. So currently in production, we actually have our 22 nanometer high-end HT1000 Speedster FPGA. We have an FPGA accelerator card with the HT1000 in a PCI form factor. And back in October of 2016, we launched our SpeedCore embedded FPGAs, which will be the focus of today's presentation. At the bottom here, we have shown our corporate offices. Our headquarters are in California, and we have an engineering office in Bangalore, India also. So what is SpeedCore? SpeedCore is our high-performance FPGA core. It's an embedded FPGA, which is available to be added to your device. So I've shown here a picture of an ASIC, a traditional ASIC. Everything in brown is basically whatever custom circuitry that you build in your ASIC. And in the bottom left over here, we have the SpeedCore embedded FPGA. The reason why you want to put something like that here, and we're going to go into more detail in later slides, but it does provide for additional flexibility and compute acceleration. The important thing is that we work with your technology node, your metal stack, your process, and ultimately, this is not a fixed embedded IP. So based on whatever your requirements are for the programmable logic, we configure the embedded IP to fit your needs. So you determine what the LUT counts are, what the memory counts are, what the DSP density is, the IO counts. And as part of any other IP deliverable, we do include the GDS2, left files, lib files, spice netlist, power models, so on and so forth. And so that's really all the hardware deliverables that we have, and then on top of that we have our software stack, and for that we provide a custom version of our Achronix ACE, which stands for the Achronix CAD Environment Tool Suite. I have some slides going into more details there again, but it includes tools for synthesis, place and route, timing analysis, debug tools, and like I said, it is custom configured for your device. So in the next 2 slides, I'm going to be going over how a SpeedCore embedded FPGA can be used for processor and algorithm acceleration. What I've done here is I've borrowed this block diagram from the Sci-Fi Freedom U500 RISC-V based SoC. And in the original block diagram, where you now see the Achronix SpeedCore embedded FPGA in green, there is essentially a set of custom accelerators. And that's where we believe that the Achronix SpeedCore embedded FPGA would be a perfect fit as an acceleration platform. And the reason for that is because it provides for high throughput, low latency, coherency, and programmable acceleration. So just to give a few numbers, an Achronix SpeedCore embedded IP with a 128-bit interface running at 600 megahertz at the interface, which is fairly typical, will provide for 768 gigabits per second with a round-trip latency of just a few clock cycles. Even when you compare that to a PCIe Gen 3 by 16 interface, you can see that in both cases you have orders of magnitude differences. We can connect to the tile link cache coherent interconnect, allowing for coherent programmable acceleration, and we also support AXI or other on-chip interfaces also. I'm going to be stating this over and over again, but you control how many lookup tables, registers, DSPs, BRAM blocks, LRAM blocks that you'd like to see in your embedded core. And one of the new features that we're launching now is, in addition to the standard tile types that you would see in a standard FPGA, we will allow customers to put in their own logic cores. So where you see in orange in that block diagram, it says actually your logic here. So that's a custom IP block. So a portion or a tile column in the embedded FPGA will be dedicated to whatever custom function you want to implement in your core. The block diagram doesn't show it here, but if needed, or if the application will benefit from it, the SpeedCore embedded FPGA can also have its own L1 cache. So the second slide is again on processor and algorithm acceleration, again using the U500 SoC. This time, the SpeedCore embedded FPGA is actually inserted in the middle or right above the protocol stack and right underneath the system interconnect. So this kind of acceleration will be used for essentially I/O acceleration. And with this kind of a fit, we can support multiple PCIe-based protocols like C6, OpenCAPI, Thunderbolt, as well as programmable protocol extensions, programmable TCP/IP acceleration, and programmable packet inspection. You will notice the emphasis on the word programmable. Obviously, that's where a programmable logic solution like SpeedCore really adds value, because the high programmability, like I said earlier, provides for the flexibility that you need to future-proof your system. With an implementation like this, you'll have runtime accelerator selection, so you can switch between different accelerator types dynamically as needed. And one of the great things about the SpeedCore embedded FPGA is the very fast reconfiguration times. So for a 100,000 lookup table implementation with some amount of memory and DSPs, you're looking at a configuration time of about 2 milliseconds with our widest programming interface running at 100 megahertz. So I want to talk a little more about the SpeedCore embedded FPGA compiler flow. The way it works is, on the left, you'll see we have inputs. So the top left is a proprietary tool that we developed, which it's called the SpeedCore die size calculator. And what it does is it allows customers to specify the lookup table counts, the memory counts, the DSP counts, the aspect ratio of their core. And we take that information with the Foundry process node, process variant metal stack, feed it into our compiler, and generate 2 buckets of deliverables. The top right shows the IP deliverables, so these are the hardware deliverables, the GDS2, the simulation files, SIPI, test models, characterization, documentation, and in the bottom right we have our full support in our ACE design tools, so that's our software stack. So taking a closer look at the ACE design tools and supported features, obviously our ACE design tools do support Verilog, System Verilog, VHDL, timing analysis, supporting CRPR, OCB derating, multiple corners. The back end of ACE is entirely in Tickle, and on the front end you can use a GUI interface or command line control. We have support for all current simulators, including VCS, QuestaSim, Alok, Riviera, and Cadence Incisive. The tools can be provided in Linux or Windows, and we are shipping production version 606 right now. So on the right side, what I've shown here is all the different things that are done in ACE. So anything with a green background, such as IP configuration, place and route, timing analysis, bitstream download, and in-system debugging are all done within ACE. The one piece that's not is synthesis. And for that, we use a third-party tool. We use an Achronix OEM version of Simplify Pro from Synopsys, and it integrates very well into our ACE toolset. In the next few slides, I just want to show you a few screenshots of ACE, just to show you how mature it is and all the different features that are available for it. So ACE is composed of perspectives, and in each perspective you have a certain number of windows, and these windows are called views. And so what I've shown in this particular screenshot is the project setup and compiler perspective, and you can see we have a number of different views. On the top left we have the projects view, on the bottom left the flow view, options view in the center, reporting on the right side, and the Tickle console on the bottom. You may notice if you've used tools from Altera, now Intel, or Xilinx, that it is very similar in look and feel to some of the tools that they offer. And I think this makes the transition a lot easier for many of our customers. The next screenshot is from our floor planning and placement perspective. You can see here in the center the floor planner view. We actually have a zoomed in view of one of our programmable logic cores. And each of those squares or rectangles represents one reconfigurable logic block with 12 lookup tables. And you'll notice a lot of thin white lines running all over the place. That's essentially our routing interconnect. So as a tool, obviously a floor planner view like this is great for debug, but we also do provide capability for ECOs. And the last screenshot is from our FPGA programming and snapshot debug perspective. On the left, you'll see our programming options, and on the right-hand side, you'll see a VCD file being displayed. And what this is basically a waveform that is output when you use our snapshot debugging tool for in-system real-time debugging. The communication between ACE and the speed core embedded IP is done through a JTAG interface. So once the data is captured, it is displayed in our ACE GUI window as seen here. With SpeedCore, we do provide extensive documentation. All of this is available on our website for download. We do obviously have a data sheet, but we have, thousands of pages of documentation for things like ASIC integration, DFT and test, software integration, configuration, bitstream programming, power synthesis, simulation. And we are obviously continuing to work on refining this documentation and adding features. So if you are interested, please, I'll be happy to point you to them. So in summary, Achronix is a profitable 12-year-old company. We have extensive experience designing, manufacturing, shipping, and supporting IP devices and boards. With a SpeedCore embedded FPGA, we're providing for high performance, on-die programmability with extreme throughput, latency, and power improvements. And again, the important thing here is customization. Each of our cores is tailored to your needs and your design. The size, the lookup table counts, the memories, DSPs, IOs, technology nodes are all geared for your needs. And with the embedded FPGA IP, we provide our ACE software stack, which is a mature, full-featured FPGA design suite with over 100 person-years of investment. And it is currently being used in hundreds of FPGA designs and dozens of SpeedCore designs also. Okay, thank you.